Hello, this is Matt Nelson, and in today's video, I'd like to do some stochastic forecasting of a stock price. Stochastic motion is referred to as the random walk, and we can define this by descriptive statistics over the empirical data coming from historical stock prices. So, to make it interesting, let's choose a stock at random from the Dow Jones Industrial Average. So I have a list of the components of the index here. And if we go to random.org, we can choose a number between 1 and 30. And this time it was the first one. So that makes things very simple. So the first one in the index is Johnson & Johnson. So let's click the hyperlink. And go to historical data. Then we want to extend this to 5 years of data. And then download once it loads. We want to open our CSV file with Excel, not a text editor. In order to get the results out of comma separated values in column A, we can use the text to columns feature, delimited by comma. And now we have our data. So to begin, let's take the daily return using continuously compounded interest. So to get the daily return, we take the natural log of the adjusted close. We want the adjusted close because it takes into account reinvested dividends. And then extend our daily return down. Next thing to do is to take some descriptive statistics. So we'll start with some averages. So the daily return averaged this amount here. So about 0.04% on a daily basis. To annualize, we need to multiply it by the number of trading days, which is 252. And that gets us a return of 8.8%. The next descriptive statistic we need is the standard deviation. And this is the standard deviation of a population. And then to figure out the annualized standard deviation, we need to scale this with the square root of time rather than straight multiplication. So to annualize it, we take the daily standard deviation, multiply it by the square root of time, the number of days. So, risk for return, we get a return of 8.8% for a risk of 19.5. But this isn't the figure that we're going to be using in today's model. What we're interested in is the daily drift rate. So the daily drift rate is going to be our daily return, the mean, plus 1/2 of the variance. So we take 0.5 times the daily standard deviation squared. And that gives us a daily drift rate. So we can trim this number of decimal places down quite a bit. And now to build our model. We want to forecast T 5 years into the future. It gives us a count of 5 times 252, which is 1260. And the current stock price that will begin the random walk is at the bottom of our list here in column F. So to begin the model, we'll make columns for T, Z, and P. The Z value is the inverse of the probability function. So we want to assume normal standard deviation, and at time equals 0, there's going to be no daily drift applied. So our stock price is where we start with, 134.17. And then we want to extend our list to 1260. Which is 5 years of trading data. The Z value, we're going to take the normal standard inverse function and then assign a random decimal point between 0 and 1 as the probability. This gives us the number of standard deviations. Extend that down. And now to apply the daily drift. So we take the stock price the day before plus the number of standard deviations of the drift rate times the daily drift rate, and press F4 to lock that down. And then again, recursively, we're applying that percentage or that amount of drift from the previous stock price. And this gives us a random walk projected into the future. So what does it look like? It could be sometimes we will lose money on the stock, sometimes we will gain money on the stock. But regardless, the stock price changes based on the daily potential drift. So when we started at our first price, time equals 0, we had 134. And after 5 years, we have at the bottom of the list, not much change at all. So that gives us a 5-year return. So compounded once, was 1% for this last calculation attempt. We want to change the compounded once every 5 years to compounded every year in a 5-year period. So that's changing the formula for compounding interest. So the annual rate will be 1 plus R divided by 1, so we don't need to do anything, then multiplied by 1 over T. So again, it was compounding once, and now we're going to compound it 5 times, so 1 divided by 5, number of years, and then take off the 1. So basically, it's near to dividing by 5, but not quite because it's a geometric series. And now we need to do a simulation. So it's not enough to just calculate this chart once. That's completely random. What we want to do is take the results of many iterations of this projection. So we'll start with taking our annual rate and then we'll run a simulation 2,000 times. The exact number of iterations doesn't matter. Now, to get this to recalculate the random walk 2,000 times, we're going to use a data table, data menu, what if analysis, and then data table. And the column input is simply going to be a blank cell. This is going to trick the computer into iterating the simulation without any change in the inputs, because the only thing that's changing is the random number. Now, to save computer power, I've put my calculation options to automatic except for data tables. So I need to calculate the sheet to actually do the simulation. All right, so now we have a result set of 2,000 projections. So we need to make a histogram to see what this looks like. And then we can take descriptive statistics to find the mean. So first of all, we want to see what the lowest number is. So we'll take the min, and then the max. So it looks like our simulation is projecting between minus 0.1, let's change this to percent, or minus 1% to positive 1%. So we can then make our buckets for a histogram. These are called bins. So we'll start with minus 1%. And then extend this to 1.5 perhaps. To make a histogram, highlight the cells to the right of the bins, make sure it's completely highlighted and the active cell is on top. Then we'll enter the frequency function. The data array are the data points from our simulation. Press F4 to lock that down. And the bins are to the left. And the crucial thing here is to press Control-Shift-Enter. And that gets us a histogram. So we can chart this. We can add the labels. And we can make the histogram look a little bit more traditional by changing the overlap and gap width. And that's our distribution. Now, in terms of our expectations for this projection, we can take our simulation and do descriptive statistics. So to do that, we go to the Data tab, then Data Analysis, Descriptive Statistics, and we're going to clear the last inputs. We're going to make a new worksheet called Stats, Summary Statistics with confidence level for mean of 95%. So in this particular exercise, we ended up with a very slightly positive return expected. So take it with a grain of salt, of course, but this could be useful in certain applications. But overall, this is how to do a stochastic forecast. I hope you enjoyed this video. Please remember to like, comment, and subscribe.